Hello everybody, and welcome to listen to this Planmeca Romexis implant planning workflow video. So in the next minutes I will be showing you how to do implant planning in Planmeca Romexis software and how to finalize it in your own designed implant guide that you can do even chairside. So first of all, I will open up the 3D image for the patient, the CBCT, and we start by mapping the dental model to this image. So we have an intraoral scan for this patient, and we select it from the patient's data list. You could as well bring any other STL file from other systems with this browse button. We need to give 3 points in common for Romexis to do the mapping. So we try to select the points as far away from each other as possible. We always select 1 point from the left side image and then the same from the right side image. We let Romexis calculate. So Romexis will not only use the 3 points that I have given it, but it will use a special algorithm to make the match even better. Romexis shows me a deviation map. So when the crowns are green and the gingiva is red, the match should be good. So we select to use automatic match, and then we will still want to verify the match, for example from the coronal view by scrolling and checking the fit of the STL model to the CBCT volume. After that, if we also have made a restoration design already, we can match that to the volume as well with the same fit model tool. Romexis notices that this crown has been designed on top of the already matched intraoral scan, so the crown will drop automatically to the correct place. From here we can move on to the implants planning module, and there we will go to the implant library to select our favorite implant. I will use Straumann in this demonstration. Once we select any implant from the library, Romexis gives us a list of the possible surgical kits. In this case I will use Straumann's own sleeve. We add to plan, and then I will use this implant centric view to place well the implant. So these two slices are always centralized in the implant, and I also see the cuts from the restoration design here, so I have a good overview on how I want my implant to be positioned. Once we have found the good place for the implant, then we can look at the sleeve. We can see clearly from the rendering that the sleeve is now entering a bit the gingiva, so we, depending on the implant manufacturer that we are using, we might be able to adjust the position of the sleeve to different heights. Once we have selected the wanted height, we can also check from the sleeve properties the needed drilling length. After having the implant and the sleeve well in place, we can move to the implant guide designing. The implant guide designing, it's a very easy workflow. We start from the step 1 and we move downwards. So the first step is to set the insertion direction. The insertion direction affects how the guide will sit on the patient's teeth, and we want it to sit so that it doesn't fall over to the buccal or the lingual side. So what we must check here is that we have contact points for the guide equally on both buccal and lingual side. So the contact points are the green areas and the red areas are undercuts. So I want to rotate the model and click set manually from the viewpoint of my insertion direction and check that I have green areas both buccally and lingually. The second step is to draw the guide area. So with the mouse left click, we select the area that we want to create the guide onto. And with the mouse right click, we can remove areas. So mouse left adds, mouse right click removes, and with the mouse wheel in the middle, you can rotate the model. And if you don't have a mouse wheel, you can as well use the Alt button and the left click from the mouse. After this, we have guide options. So we have a thickness value. Generally, a thickness between 2 and 3 millimeters is recommended. You can choose that freely. Then these two gap parameters, they affect to the fit of the sleeve and the fit of the guide. So those you might need to adjust depending on which 3D printer you will be using for printing the guides. We have here by default the parameters for our Creo 3D printer. In the step 4, we have parameters that define the plane area just around the sleeve. So we have parameters that have been locked because they are parameters that define the hole for the sleeve and should not be modified unless we are advanced users. That's why they are locked, but can be unlocked from this small lock. The wall thickness is the only parameter that we can safely modify. It defines how thick will be the area of the guide around the sleeve, and that is generally recommended to be a bit higher than the thickness of the whole guide so that we get more strength just around the implantation spot. After that, in step number 5, we have a possibility to select to remove sharp and thin edges. This should be always selected when we do real patient cases. And after that, we can create a preview of the guide. So Romexis will calculate a preview of the guide, which we can then still modify a bit. So we can, for example, remove material. So for example, if we have some unnecessary parts that we want to still remove from the actual guide, we may as well add inspection windows wherever we wish them to be. We can also add a bar if we need to add more strength to the guide. And we can also add a text. So we rotate the model and we place the dialog on top of the guide where we want to place the text. We can also look at the guide without anything else to check if we are happy with the design. And then we are ready to create the actual guide. And Romexis will create the STL file for the guide. It will as well be exported at the same time to your selected location, and you will be able to even create implant report. So after creating the guide, it will be visible here on top of all the other patient data, and it can be managed from here from the object browser. So from here, you just then bring it to any 3D printer and print it with the surgical guide compatible material. That easy to create your own guides locally. Thank you very much for listening, and bye bye.